CNC machines, or as you say, computer numerical control, have been around for more than a few decades. But nowadays they have become so popular that many have them or want to have them at home. The build behind me, which is my 1 square meter plasma plotter, may not be the best plasma plotter out there, let's be honest. But for now it demonstrates a simple cause, and that is the brains on which it runs on. Let's talk a little bit about what you're seeing here. So when picking electronics for this build, I went with an Arduino Uno and a CNC shield on top of it with stepper motor drivers, which is the way most people go with when they're, say, starting with CNC machines. And there is nothing really striking about this, because you can get the basic electronics for like 50 to 70 euro, even while using an Arduino, which is original. And these parts are quite easily available pretty much anywhere. So I wonder why people use it, right? Except this isn't working. Why? Trying out 3 CNC shield boards, 3 sets of these stepper motor drivers, TMC 2208, 2209, and the RV8825s. While trying it on 2 Arduinos, one of them was a clone, the other one was original, I just realized that this is really not the way to go about building CNC machines. Not only are the CNC shield boards quite fragile, but there are some other issues with this. And one of the biggest concerns I have about this is it runs on a USB connection to a computer, meaning that if the connection is interrupted during the process, it just interrupts the whole process, and you have to have a computer next to it. Now, setting the potentiometers on the CNC shield is quite tricky. It's, again, possible, but very tricky. You have to have a multimeter connected, one probe to the screwdriver, the other probe to ground, and you turn the potentiometer until you get the desired voltage, which you then recalculate to the desired amps, which you actually want to have run to that axis, which, it requires some practice. One other thing is that the motor voltage runs through the CNC shield board, which I don't find like a great solution. I'm kind of worried about the board because I've already burnt out at least one of them, if not 3. And then there are also other things like, let me remind myself of what is the issue with this. It runs on DuPont connectors, even for the motors, or JST-XH, which are pretty much approximately the same cross-section allowance. Not only are they, again, fragile, but in case anyone wanted to build a bigger machine like this, or even bigger, they're kind of limited with the current they can run through this. So again, like, this is, it's possible, but it's not a way to go for me anymore. Then I have spent quite a few evenings looking for a non-industrially priced alternative to this, and I have found quite a few solutions, like say X-Pro V5 Mac boards, other microcontroller based boards like Raspberry Pi or Corgi boards on ESP32, and like, yes, there are those things on the market, but none of them really fulfill the plug-and-play solution for a build like this. So they are either bare boards without an enclosure, and or they have many of the same issues as this GRBL does. And the real challenge was to find a plug-and-play solution that would have a stable Ethernet connection running independently of a computer, which is essentially what I wanted from the start. Now, can you imagine how many people could actually have and use CNC machines at home, be it in order to make stuff for friends and family or run businesses based on them, if there was a controller that was much easier to set up, had internet connection, and was available? Now, let me know what you think about this and what are the features you'd really want to have in a CNC controller like this. Throughout my life, I have come across many people who were really manually skilled and creative, but they are not the types of people who want to tinker around with electronics and programming. So aren't you perhaps one of them? Let me know, and thank you for